Alright, so here's the start of a new thing that I'm going to be doing, which is these longer videos, expanding on those short concepts. So this first one is about entropy, and more on the heat death. Fun stuff. So, entropy is often regarded as like the measure of disorder in a system, and a fun way to look at that is, so right now I have these little coins, and then now is disordered. And the reason why it's fun to look at that, still disordered. Entropy is always increasing, and because that's a statistical thing, it's more likely that these coins, the system, is going to be in a disordered state than an ordered state. If I keep shaking this up, it is very unlikely that it's going to get back to the split pennies on this side, dimes on this side. Like, it's not going to happen. It's very unlikely. So that's why entropy, this disorder, is always increasing. But the other definition of entropy is the measure of energy unable to do work. So it's how spread out that energy is. So that's where we get more the heat death aspect of it. So as this entropy is always increasing, and in the universe this entropy is always increasing, we have a universe that is constantly being heated up, cooled down, because the entropy is always increasing, so the energy, there's more and more energy that is not able to be used. So with less energy able to be used, yeah, less stuff happens. So the universe begins to cool down, less stars are being born, planets don't have energy, civilizations don't have energy, all that stuff. And the way that this kind of came about is from the second law of thermodynamics. That's where we get entropy. And it's, if no energy enters or leaves an isolated system, the entropy of that system increases. And yeah, I just explained how that happens. But that's the second law, and from that we pretty much say that the universe is an isolated system, and if the universe is an isolated system, that no energy is being put in, and like, if there's some outer force putting energy into the universe, making it go, then this wouldn't happen. But from our current knowledge, well, that's not happening. So this is a possible ending of the universe, where the universe is just constantly increasing in entropy, and energy is being less and less usable, to where eventually there's no energy, and the universe just dies out in heat because it's reached a maximum energy state. And a way to look at this is like, gonna use my coins again. This is gonna be weird trying to use this. So okay, there. I'm using a webcam as a mobile, so this is not working very good. But here, like, things can interact, they can do energy, and that's why when things are close together in an ordered thing, they have a lot of energy. But as entropy increases and this energy and all this stuff is spread out, they can't interact. Has nothing to interact with. So as the universe is getting spread out, it starts to cool down because there's no interactions that it can have. And that's how the universe cools down, and it has this heat death because nothing happens. And stars die out because they don't have that energy, and even black holes will begin to die out because of something called Hawking radiation. But honestly, I'm gonna get into black holes in another video, because they deserve a long video, because black holes how they're formed, how they die, how they're sustained. They're pretty wacky. But yeah, that is an idea of how the universe will end. The entropy of the universe just increasing to its maximum point to where there's no usable energy in the universe and everything just cools down. It's also referred to sometimes as the Big Freeze, if you want to find more information on that. But yeah, pretty fun idea. The universe just getting so cold that everything dies.